flying across the water. But this is no ordinary speedboat. It's one of the latest designs using the hydrofoil system, which raises the hull from the water and travels smoothly above the waves. Hydrofoils are experiencing a resurgence, with several small companies developing new vessels, many powered by electric motors. The hydrofoil concept dates back 160 years to the patent issued by Frenchman Emmanuel Farragut. Essentially, a hydrofoil is a wing attached to the vessel's hull.
So the fundamental principle is you're trying to generate lift. You're trying to generate a vertical force to either relieve some of the displacement of your vessel or to just take it out of the water completely. And what it does is it reduces the drag, it reduces the resistance that's holding back your craft from advancing through the water. So practically what that means is that for a given power, you can go a lot faster.
It took Fargo 30 years to build his first workable prototype. With multiple struts and underwater wings, the craft surprised many onlookers by achieving 36.9 knots, a little over 42 miles per hour. Pretty incredible for a small vessel in 1906. Strangely, this is where the telephone inventor Alexander Graham Bell comes into the picture. Along with a partner, they created a massive 5-ton hydrofoil vessel at the end of World War I. The Hydrodome, as it was called, although ungainly looking, set a new world record over water at 61.58 knots. That's a smidge under 71 miles per hour. So, the hydrofoil concept was proved, but it appears to have been completely forgotten until the 1960s and 70s. From the early 60s, the Soviet Union embraced hydrofoils in a big way. Hundreds were built to ply the country's rivers and lakes.
Hydrofoils were kind of high fashion in the 50s, 60s, into the 70s, really. They were used a lot on the Russian rivers, for example. They had these Russian river rockets, the Kometas, and so on. I think the main reason is that traditional hydrofoil technology has some drawbacks. It's in theory more energy efficient than conventional vessels, but the focus was not really on energy efficiency back in the days because with combustion engines that's not really an issue. And the drawbacks with traditional hydrofoils is that they have a certain draft, right, because you can't retract them, so they're kind of hard to dock. They're not really suitable for all weather conditions. If you have a certain sea state, they tend to oscillate a bit, and it can get pretty nasty on board. And also it's a pretty costly system for a conventional boat as well, with a fossil fuel engine.
These Russian boats couldn't be described as full hydrofoils.
You have hydrofoil assisted, where you're still getting some of your lift from buoyancy. So you're still within what we would call an Archimedean mode. You're generating lift from Archimedes' principle because of the buoyancy of your craft. And then you have a fully foiling vessel, which now is completely out of the water, and all that's left in the water is going to be part of the hydrofoil.
It took Boeing's use of aviation technology to create the first hydrofoil passenger ferry to lift it all the way out of the water. Carrying up to 300 passengers, the 929 jetfoil has gas turbines powering water jets to push the massive craft at up to 45 knots. But after the limited success of the Boeing jetfoil, hydrofoil development appeared to stall again. It wasn't until competition sailing, notably the America's Cup, began to adopt hydrofoils on racing yachts that development stepped up a gear.
All of a sudden you have what is essentially, the pinnacle of sailing that's using the technology. It made the vessel a lot faster, it made the racing a lot more impressive. What it also did is it brought the racing a lot closer to shore. Because with deep, long keel, previous vessels had to often sail quite far out, whereas now you can sail a lot closer, so you have a lot more spectator. So there is definitely a fashionable element to the hydrofoils. Just like, in race car you have a rear wing, and on sports car you're going to add one and all of a sudden it looks racy. So that's definitely helped. There's obviously been also at the same time a big increase in our concerns about the environment, the amount of pollution that we have, and hydrofoils, by the fact that they can reduce fuel consumption, make a very big difference.
The manufacturers of today's hydrofoils owe an enormous debt to the pioneering of the America's Cup races.
There's this concept called adjacent possibilities. And it's a concept from evolutionary biology, which basically says that new organisms become possible based on what's happening around them. That's why Uber Eats is now a thing, but before the iPhone, it was not a thing. It became possible because of the iPhone. So what's happening in the world today? Number one is the America's Cup and what that's done to hydrofoils themselves. We now have hydrofoils that are more efficient than what we had before. They're also made of cheaper materials. Metal is actually quite expensive when you talk about complicated shapes. Composites, relatively inexpensive. Literally, the software and the simulation software has come miles, making it sort of quicker to develop one of these types of vessels. Now, the second area, that's the EV automotive space. Marine's a big industry on its own, but it's not as big as automotive. And so what we're seeing now is a trickle down of low-cost automotive components for electrification into the marine space. And actually, if you look at EV sales, it's really only started to pick up since 2020. In 2020, it was like 14% of new sales. So we're not even that far away from the real pickup in automotive. And the third one, and this is what people forget about quite often, is just robotics and drones. Whereas the computer that was on the Boeing 929 took up an entire room with analog circuits, you can now buy a consumer drone for a couple $100s that has all the same computing hardware. The math has literally gotten better too, the way we control vehicles. And low-cost actuators and all that are now more available on the market. So what we're seeing today is an entirely new class of vessel. We didn't see actively controlled hydrofoils that were in the size ranges that we're talking about at the efficiencies we're talking about. So it's an entirely new thing.
The new hydrofoil designs could have been constructed at an affordable price 30 years ago. New composite materials, software and battery technology have all played a part.
You need to build a very light boat in order to make an efficient boat. So you need carbon fiber composites, and those were not really available in the 90s, or if they were hyper expensive. It's the stuff you could only afford for certain fighter jets and so on, right? But that's become accessible for boat builders. So we make our vessels out of carbon fiber, which makes them very, very light. And the other thing is that's electronics, right? So computers, which we use to stabilize the boat, because once you have a hydrofoil system, a fully submerged hydrofoil system, you end up with an inherently unstable boat. So once the boat is flying, you need to balance it by adjusting the angle of attack of the hydrofoil and also sort of twisting it or angling it. It's kind of like balancing a pen in the palm of your hand, because the lifting point is below the center of gravity, right? These kind of computers were super expensive 20 years ago or even 15 years ago. The technology found that in jet fighters and some commercial airliners as well. That's why Boeing, they had a 929 jet foiler back in the 70s, 80s. That was basically a spin-off of the military arm of Boeing. That kind of technology has been commercialized by the revolution of smartphones and also drones. That's the software and hardware in a drone is pretty similar to a hydrofoiling boat, although less expensive, right? And then the third thing is batteries, right? The boom in electric cars have produced better batteries. So we have energy-dense lithium-ion batteries these days that were not available even 10, 15 years ago.
The twinning of electric power with a hydrofoil brings together two ideals.
It makes sense to have hydrofoils with electric vessel because you typically have slightly less power, or because you're trying to maximize the battery life. And so this is why a lot of electric vehicles have found a lot of benefits from hydrofoil. It's not necessarily better or worse. You could have a different form of propulsion on a hydrofoiling vessel, be it something that's fully sailing, being something that's hydrogen propelled, whatever you fancy. But it's this need to either reduce emission or to get as much as possible from a limited power or energy supply.
And the boat builders at Vessev have practical experience of how efficiently mating an electric power plant with a hydrofoil can be compared to a regular craft.
We have a chase boat that we have been using during development and testing of this thing, and it does all the same routes, all the same exact runs that we do, exact same speeds. After almost every day of testing, we would put 15 times more cost in fuel in the chase boat than electricity in the VS9. And that efficiency difference comes from, it really comes from a couple different places. One is electricity is so much less expensive than fossil fuels. If you equate the costs of electricity kilowatt hours to usable kilowatt hours in fossil fuels, it's roughly 3 to 5 times more expensive. So that's why electric cars are cheaper. But then we have this other hack, which is the hydrofoiling, removing the boat from the water completely. And that, it's up to a 5 times increase in efficiency. So when you stack those two things together, 3 to 5 times X on electricity, and then 5X on hydrofoils, you get this massive efficiency gain. And that's where we get to 90% lower cost of operation.
All current electric-powered hydrofoils being designed or manufactured are smaller vessels. Companies have started small with leisure ferry boats and are extending the range to commuter ferry boats. However, it's not as simple as saying the bigger, the better.
If you look at these big cargo ships that you have out on the ocean, those are actually very efficient vessels because they're just gliding through the water. So the hydrofoil concept is something that fits slightly smaller vessels up to, say, 40-50 meters, something like that. You can make a 150, 200 passenger vessel. The reason we've made a 30 passenger vessel is that we believe that the waterborne transit system works better with smaller units. If we look at Stockholm, for example, where we will use the P12 shuttle in the public transport system this year. We have these conventional diesel ferries running around in the archipelago, and those are for 250 to 350 passengers, but on average you just have 50 persons traveling with them at any one time. And that means that you're running around with a lot of empty seats, which makes for a system which is super inefficient. You have very few departures a day because you have these big vessels, and they're also quite slow. So if you change this system to a more nimble system with more but smaller vessels, you can have more frequent departures, faster travel times, and much lower operational cost as well. So it becomes like a bus system but on water. I mean, you wouldn't be super happy if you had a bus line and twice a day a 350 passenger bus would pull up at your bus stop and just like 50 persons step on board. It's a waste of resources, and the same goes with waterborne transports.
So, will we see hydrofoils getting faster and faster? Probably not.
As you make these boats go faster and faster and faster, you actually need to make all the structures thicker and thicker and thicker and thicker. A 50-knot hydrofoil, they exist, actually has quite thick struts to handle the structural load cases. By focusing on slower speeds, 25 knots up to 30 knots, we can make all our structures a lot more optimized for that speed and get better efficiency. And as you can imagine, when you push for 50 knots with one of these vessels and you have to make the structures thicker, well, drag squares as you go faster, and you have thicker structures. And so it's just compounding losses as you try to make more of these go faster and faster and faster.
But a hydrofoil has a significant advantage over a regular boat, which is the wake, or lack of one. As you can see in these comparison pictures, a hydrofoil traveling at 25 knots barely leaves a wake compared to other vessels.
If you look at Stockholm, for example, or New York, or any other place where you have a lot of water, then you see that vessels are traveling anywhere from 40 knots to down to 5 knots, right? You have speed restrictions, and a lot of places those are actually because of wakes, right? Because ships at speed create big waves, and those waves can damage shorelines. They can, damage more boats and so on. So our vessels don't really create any wake. The wake from the P12 ferry is about this high. It actually looks surreal when you look at it. But once you're starting to fly above the water, you don't displace any water, and hence no wake. So we've received an exemption from the speed limits here in Stockholm. So we can fly at close to 20 knots inside the city center. And the city center, that particular stretch of water is 550 meters wide, right? But usually the speed limit is 22 kilometers an hour. If you look at a freeway, You can go 120 kilometers an hour on a road which is 6 meters wide, right? So I think we'll have to start looking at the speed limits. Why are they actually there on the waterways? Is it for safety, or is it for wakes, right? And if it's just because of wakes, we should probably have a think about if we can go faster and utilize those waterways better.
And those rules and regulations, such as speed limits, are slowing the development of hydrofoils.
A lot of the rules and regulations don't actually consider hydrofoiling vessels. There have been now an inclusion of hydrofoil assisted vessels, but for fully foiling vessels, a lot of the rules and regulations still don't necessarily apply. So it makes the process more difficult, more lengthy, more expensive to get a vessel out there. So as the rules react, and as we start understanding more what do we need to include when we have a hydrofoiling vessel, that I think is going to really help the wider adoption of it. And there's a lot of challenges associated with it that are hydrodynamic, that are structural. So for us, one of the key principles is maintaining the watertight integrity of the craft. So what happens if you hit something? There's also slamming loads. So as you come off the hydrofoils quite abruptly, maybe something happened. Again, you might see slamming loads which you wouldn't necessarily expect on the vessel that you have. So these are big considerations that we're trying to bring into regulations. And then you obviously have the physical scale of them, moving away from small boats onto larger and larger vessels.
Let's not forget the cost of these revolutionary new vessels. Although the running costs may be minimal, the boat comes at a premium price. The list price for smaller leisure hydrofoils is nearly $500,000. For commercial operators, the economics of running an electric hydrofoil ferry are stacked in its favor. However, it's still an exclusive toy for the rich in the leisure markets.
Remember to hit the subscribe button and ring that bell to stay updated with our latest content. And while you're here, why not check out another one of our exciting videos? Thanks for watching, and see you in the next one.